So today I'd like to speak about DevOps without the ops, and whether it's a fallacy, dream, or I don't know, both, neither. And it's based on the story of how Wanelo, the company I worked for, had handled thousands of writes and reads per second in our kind of a Ruby on Rails stack, all without the operations team achieving 99.97% uptime without really trying super hard. So I kind of thought that was really like, oh, this is cool. Like maybe we can share some things that we've done that will help other people to come out and build applications that are resilient and don't necessarily require an enormous ops team. Oops, this is really fast. So real quick about Wanelo. Wanelo is the shopping mall of the future. If you're not familiar with it, you can think of it as a blend between Tumblr, Twitter, and Facebook, all surrounded by shopping. You can follow people, you can follow stores, you can follow collections, and it's all personalized feed of products. It's infinite. You'll just get lost in it. We've got about 350,000 stores represented, 20 million products, and these products have been saved over 3 billion times by users. So again, think of us as like Pinterest, smaller, all about the products, but still pretty big. We're launched in 2012. We've got about 35 employees. We're a pretty small, still team. About half of those are engineers. So next, I want to talk about what people talk about stack. You know, they're like, what is your stack? Are you running on things? What are you doing? Are you running on Mongo? No. Whoa. Yeah, no. Stack is really, really loaded question, and that's why I put this slide together. It is not meant for you to really read into it right now. It is meant to be maybe for you to dig into it later after you watch the presentation. But the point being here is today's applications, today's Rails, Ruby, whatever applications we build rely on such an enormous amount of components, enormous amounts of open source tools, as well as paid services. And so it's really kind of silly to be talking about stack unless you have like, 2 hours to kill. There's a lot of stuff to talk about. Next, real quickly, I want to talk about the traffic to your app. So if you're building a Rails or Ruby application and you're doing something maybe for mobile or whatever, you're receiving traffic. So, if you're just building an internal website, you can be probably expecting something along the lines of 100 requests per minute if you have a lot of internal users. If you're building something for public and it's a little bit more of a popular application, maybe it's 1,000 or 2,000 RPM. Once you cross 100,000 RPMs, which is 100,000 requests per minute, you're now dealing with scale issues for sure. And of course, when you look at the top 4, maybe Pinterest, Facebook, and Twitter, I mean, that we're talking tens of millions of RPMs, right? But that is a really, really unique case. And 99% of us here do not have to worry and don't have to solve the problems that these guys are solving. But you may end up having to be solving the problems at 100K RPM or 50 or whatever. And so, so that progression from kind of this really small application to kind of mid-sized big application is the story that I'm going to tell. So what is this talk about? I want to review ops, DevOps, the cloud, how it's changing the landscape. I want to kind of point out some key patterns and points that dramatically reduce stress from writing things like that, particularly in Ruby on Rails, and also just generally kind of bring up a question like, does a modern startup or small, a new company, does it actually need an ops team per se? And so we'll start with the basic. What's the DevOps? So first definition is from the Wikipedia. I'm not even going to read it. It's a mouthful. It's terrible. The second one is actually more interesting, and it's a quote from Forrester report that just came out, and it says, today, many organizations are really confused about what DevOps means to them. And I find it really, really interesting. It's sort of this like, hey, we took Dev, we took Ops, we merged them together, boom, something happened. No one knows what. So another source, Puppet Labs report on State of DevOps says, efficient teams are deploying code 30 times more frequently with 50% fewer failures. DevOps practices correlate strongly with high organizational performance. Now, these are tangible things. These are the things we can actually look and be like, okay, maybe that's interesting. What is going on here? And so it's important to kind of understand how we got there. And so traditional heavy agile, which is, I call it heavy. I mean, most companies will call it agile. But it's basically this kind of a path where you have products pushing requirements to dev, going into QA, maybe QA spending weeks manually testing it, going to operations. I've been in a company like that. And it was, it was difficult. It was terrible. It is a bad way to build software. It's just hard. It's unnecessary. It causes a lot of pain. And so I argue that you don't need this last two, up until a certain size, up until whatever. It also depends on obviously what application you're building. Maybe if you're in the financial markets, your QA team is the absolute necessity. But if you're building like a social network or you're trying something out, that you don't need that. You can be much more leaner than that. So real quickly, let's talk about traditional ops. So traditional operations are generally responsible and tasked with what? Uptime, stability, reliability, on-call, fixing site at night, right? Backups, disaster recovery. Those are the typical things ops people do. They're also responsible for hardware. They're also responsible for networking configuration. They're also responsible for colocation and data centers. Well, the cloud changed a lot. The cloud allowed us to get rid of these things like hardware. Networking colocation is now taken care of by a cloud provider. That's really, really phenomenal. And I think that is really one of the key ingredients that's really making DevOps possible. And so that's important to acknowledge. And so next, let's talk a little bit about how to build software in a little bit simpler way and a little bit lighter and friendly. And I'll start by kind of declaring the early company goals based on Wanelo, our story. What we wanted to get to when we first started, we had about 6 engineers, 3 pairs, we wanted to maximize iteration speed. We weren't sure exactly what we're building. I mean, we did, but we wanted to experiment with different features. We wanted to launch things quickly and get them out there as fast as possible. We call this agro-agile. That's in comparison to heavy agile. So we wanted to also scale as we go, meaning that if our traffic started to climb up, we didn't want to shoot ourselves in the foot. We wanted to be in a place where we could, scale the application together with the traffic. And what that meant is that we had to continually make small investments into performance. And things like caching, things like adding the memcache early on, adding infrastructure so that when suddenly traffic hits, you're like, okay, I can just cache these 2 extra pages and suddenly I got a better latency versus, oh my God, we don't know how to do caching at all. So, and we build this in a way that prevents us from doing that. So investing little things as you go along is really, really smart. It doesn't mean you're prematurely optimizing the app. It just means that you're thinking ahead. We wanted to be able to break things and not be blamed or criticized about it and just learn and move on. And I'll skip this one, but then the final one is we want to remain in control of our infrastructure. And that was really important to me. I tried Heroku, I tried various other cloud providers, and granted, the landscape had changed dramatically over the last 3 years, but Heroku is just prohibitively expensive. There was a lot of things that it locks you in. And so we wanted to be in the cloud, but we wanted to have full control of our stack and our environment. And so while moving really fast, we just never really hired ops. But we did hire several really, really smart engineers who actually enjoyed ops work. But the difference was that they approached it as software engineering, and they approached it with the same rigor as we do approach code, building applications. And so not having ops meant that we had to deploy our app to the cloud ourselves and learn how to provision nodes. We had to learn how to get load balancers up and running, app servers, Solr, search engines, how to make them replicate, how to install and tune Postgres, all of those things. And so fast forward to today, our application is 100% hosted. We're hosted on Joyent Cloud. Most of you probably don't know Joyent. It's a bit of a boutique cloud provider. It's a really interesting one. If I have time, I'll talk about it in the end. We are 100% automated with Chef. We went through a 10,000% growth in traffic in 6 months, and we survived. In fact, we never went down. We were slow occasionally. And our users were really like, oh my God, I'm going to shoot myself. I can't browse my products. But we never really went down. So that was really remarkable. And we did achieve 99 by 97% uptime without trying really hard, because that wasn't really the goal of the company. Like CEO and founder was like, we need to build what people want. That's the most important thing. If we have to be done occasionally, that's life. And of course, as you know, or if you remember early Twitter, that doesn't seem to affect the success of the company in the end. The other thing is on-call engineers at our company only get about 1 to 2 pages a week. So that's really, really, really small. And also, almost 80% of our engineers are on call rotation. And we still have no ops team, but lots and lots of ops work. So how do we do this? So the next part of the talk is more focused on, and that's my hope, is that you can walk out of here with a very specific set of ideas and potentially patterns that you can apply directly to maybe your environment, so that you can reduce stress, reduce amount of pages, reduce amount of whatever it is that's currently plaguing your application. And so it's much more aimed at practical advice. So the very first one is the automation and deployment. Infrastructure is a first-class citizen, and it has to be treated this way. When we develop user stories, when we build new features, our pairs, because we do pair programming, they deliver infrastructure work together with their feature. So let's say you needed to add a new background worker. Great. So you added it to your Rails code, and then you went to Chef repo, and you added whatever the service needed to bring that up. And so all of that is happening in parallel, and most of the team is learning how to use both. And that just creates a really, really good environment where lots of people understand how things are put together. We also run Chef continuously on production, as opposed to there's another model where people use where they just kind of don't run it as a daemon, but once in a while they just run it by hand. I find it to be really dangerous because you never know when it was run last time, so God knows what's happened since. If you continuously run it and something goes wrong, you only have to look at maybe the last, I don't know, 30 minutes worth of commits to figure out what happened, and you have a time to fix it. We do incremental deployment. We don't do continuous deployment, but we do the incremental deployment. We roll the code out everywhere, and then we restart just a couple % of our servers. And then we start watching the errors and seeing what's happening with that, with those servers, using New Relic, typically using logs and other things. And usually a pair does that. And then if everything is okay, after about 2 or 3 minutes, they just continue rolling the rest. And so that's sort of like our deploy strategy, and it's barely manual. It requires literally 2 commands, cap, deploy, and then roll. And I really liked having that and not having continuous deployment, specifically as a leader of the company, because I want my engineers to be closer to infrastructure. If everything was just going out there for every check-in, continuous deployment, and I think at some point when we grow large enough, that will absolutely happen. But until then, I think it's actually valuable for people to be looking at HAProxy status page, looking at what's happening at the New Relic, and trying to understand how their code actually affects production. The second one is, again, probably the most important part of this talk, and it is how to build fault-tolerant infrastructure. And the truth is, I've been doing software for 25 years, and I've been in the first .com boom when we built everything from scratch, and including like hash libraries. And achieving fault tolerance today is so much cheaper and so much easier than ever before. It's really literally a crime not to do it. So how to do it? If you remember one thing out of this talk, it is put HAProxy in front of absolutely everything. Put it in front of your mom. Put it in front of your app server. Put it in front of your database. Put it in front of your Solr. Put it in front of your Elasticsearch. Put it in front of your Redis. HAProxy is amazing. It is stable. It is fast. It does not add latency. It will save your life. It will basically route across multiple servers in the backend. If something goes down, it will take it out. It will potentially even remove requests from the queue, move it into the live servers queue. And all of that is transparent to the users. No one's noticing. So our servers can be going up and down. No one notices a thing. And then Makara, TwinProxy, and DALI are sort of the same thing as HAProxy, but much more specialized. So Makara, I'll talk about in a second. TwinProxy is a little tool that came out of Twitter, and it's essentially a sharding connection pooling proxy for Redis. And DALI is in front of the memcache. And let's see. So let's actually look at a couple of examples of resilience. Sorry, how much time do you have? 5. Oh, awesome. All right, so we'll go through a couple of patterns. So this one here is where we have application essentially talking to multiple services in the backend, Solar, Web Service, Elasticsearch, all through HAProxy. And every configuration is entirely condensed in that HAProxy config. The app doesn't know where things are, and it shouldn't, because your infrastructure is large. So Makara I mentioned earlier, and Makara is basically a simple database writing tool for active record that's been in production for us and TaskRabbit, and there are two different forks. One is Postgres, one is MySQL. We probably should get together and merge them at some point, but this is sort of an example configuration on the right, and on the left, sort of set of features that it does. It automatically retries when replica goes down, load balances with weights, and so on. The biggest thing about it is that it actually works in multi-threaded environment, and we are in the world of multi-threaded Ruby. And I really hate gems that are not thread safe. So please don't write thread unsafe gems anymore. We really need them to work inside Sidekick jobs with 10 threads and so on. Replicate everything that replicates. So in this case, we're receiving writes. We want to update our search engine. We're pushing it to queue. Background worker updates the master. Master pushes it to replica. The replicas then are being read by the application. You can lose these read hosts without any impact to the user. Users aren't going to notice anything. You may slow down on your updates. You may not be receiving fresh data, but the site will be up. Another interesting pattern is, well, you have probably one or two load balancers. What happens if one of them goes down? Well, you can probably invest $100,000 in a hardware load balancer, or you can go with something like DNS Made Easy, which gives you, with enterprise account, free 10 IPs that it pings for you. And if one of them goes away, it just does whatever you tell it to do. It'll remove IP address, it'll switch it, and so on. And so the auto failover with DNS works like magic. We've certainly had that happen before. It works best with a short TTL, and we configure load balancers in pairs to fail over to each other to account for the network partitioning, so that if DNS Made Easy cannot even ping us completely, maybe that DDoS or something, we don't want to lose all of our IPs from the DNS pool, so that sort of takes care of that. The other pattern that I find really key is, and most of you are running some sort of Sidekick or maybe Rescue. Sorry about that. But if you are using any kind of background job processing, you will be probably talking to Redis in order to inject those jobs into there. And if you have an application that's getting 100,000 KRPM, that's a lot of inserts, because probably every request is inserting something. So what happens if that Redis goes down? Well, that is just single point of failure. And so what we came up with is this failover to the overflow pattern, where essentially we're keeping this little Redis, but in the HAProxy config, unlike the previous configuration, which was from load balances, so round robins, it will simply just switch to it when the primary is completely overwhelmed. And that saved us many times. Alert on only what's important. We don't alert on Nagios, host down. We just ignore it, because who cares? But what we do alert on is things like sudden drop in product saves per second. That's a business metric. And business metrics like orders per second, registrations per second, users per second, all of those are the key things that you really do want to alert and page on. And that is why we only receive 2 pages a week, because costs come up and down, but the application keeps running. All of this requires really Obsessive monitoring, and today monitoring is fantastic. There's so many different options that are probably subject of entirely different talk. And we actually run a dashboard that looks like this inside our office on the big TV. Whenever anyone deploys anything, they will immediately see if something goes into the red, for example. Maybe the error spiked, maybe something else happened. Just for reference, the tool that we're using here is called Circonus. It is not free, but it is a fantastic tool for ingesting data and graphing it and dashboarding it. And 5, Cloud Vendor is your partner. And we get phenomenal support from Joint. And in a way, I would say Joint is our ops. And DevOps is really just code. So hire folks that write code. Hire folks that have the rigor to approach infrastructure code the same way we approach our spec, we approach our features. And the summary of all of this is, here's how to reduce your stress. Insist on 100% automation. Deploy fault-tolerant patterns whenever possible. Page only on what's important to the business. Monitor everything else obsessively. Choose a cloud provider that can be your partner that you can talk to. You can't talk to AWS. Infrastructure work is software engineering. Thank you very much.